Okay, as we continue in Chapter 5, we've gone through medians, we've gone through altitudes, we've gone through perpendicular bisectors, angle bisectors. Now we're going to talk about the sides of triangles. And the sides of a triangle are pretty much what make the triangle itself. If you have really, really long sides, you might get an obtuse triangle. If you have really, really short sides, you'll get an acute triangle. We're going to look at this drawing right here, and we're going to identify the longest side, the shortest side, and then we're going to try and identify the longest angle and the shortest angle. And so what we'll do is we'll just classify them as 1, 2, or 3. The longest side. Now, using your powers of observation that the good Lord gave you, what side looks the longest? It's really not that difficult. It looks like it's this one right here. We're going to call that number 1. Now, based on what you know about angles, sides, and what we talked about last section, shouldn't the largest angle be across from the largest side? It makes sense. A large angle has a bigger area to project. A smaller angle would be across from a smaller side. Well, let's try and identify the smallest side in this triangle. We'll label it number 3. It looks like it's this one right here. Which, what does that tell you about this angle over here? That it should be the smallest angle. The longest side is going to be across from the largest angle. The smallest side is going to be across from the smallest angle. Now, just understanding that concept right there, let's look at these two theorems. If one side of a triangle is longer than the other side, longer than another side, then the angle opposite the larger side is bigger than the angle opposite the smaller side. That's like duh 101. If 8 is bigger than 5, then the angle opposite 8 is going to be bigger than the angle opposite 5. That just makes sense. If the side of a triangle is based on the size of the angle, a larger angle equals larger side. In fact, we should even write that down because that's pretty good. Larger angle equals longer side. Smaller angle equals shorter side. Maybe something you want to write down in your notes. So if 8 is larger than 5, then the angle opposite 8 should be larger than the angle opposite 5. And the next theorem says the exact opposite. It's the converse. If an angle is larger than another angle, then the side opposite the larger angle is bigger. That makes sense. Here we have 50 and 30. That should tell me that the side opposite 50 degrees is going to be bigger than the side opposite 30 degrees. Again, larger angle means a longer side. A shorter angle means a shorter side. Two pretty basic concepts there. Nothing overly complicated. And you can even see the little inequalities that they make. They say that AB is greater than BC, which makes sense because 8 is greater than 5. So, angle C, because it's across from 8, should be greater than angle A because it's across from 5. We can say the exact opposite here. Here we went from sides to angles. Now we're going from angles to sides. If angle A is bigger than angle C, then the side opposite A, which is BC, should be greater than the side opposite C, which is AB. That's where they get the BC is greater than AB. Just take what facts they give you, or what even observations you have, and then just write inequality with it. We're going to keep going because there's one more thing, and it's the triangle inequality theorem. The sum of the lengths of any two sides, any two, is greater than the length of the third side. The sum of any two sides should be greater than the sum, or should be greater than the third side. Now that kind of seems unimportant. But once you start looking at the size of triangles, or the lengths of the sides, it really, really matters, especially when you're identifying, okay, this is the shortest side, which means that this is the smallest angle. This is the longest side, which means that's the longest angle, etc. Knowing the lengths and being able to classify that as longest side, shortest side, largest angle, smallest angle, really comes into play. Here's a little note. Look at the three triangle constructions below. See how the first construction forms a triangle where the sum of any two sides is greater than the third side. And what I want you to see there is if we add any of these two up, it will be greater than the other side. Like 4 plus 2 is 6. 6 is greater than 5. 5 plus 2 is 7. 7 is greater than 4. 5 plus 4 is 9. 9 is greater than 2. Every time we add two sides together, it's larger than the third side. And so what we're going to see is if the three sides don't follow that inequality, then you'll actually see what we'll get. Here we have we have three sides, actually, not a triangle. But let's look at the sides. If we add two sides together, like 2 and 2, if they're not greater than the third side, notice what happens to our image. If this side plus this side is not longer than this side, then the sides won't even touch. You won't even get a triangle. Then again, let's say you add two sides together and they're exactly equal to the third side. They're not greater than it, they're just equal to it. Well, they'll actually touch, but they'll touch right here on that bottom line. And so you won't get a triangle, you'll just get three line segments that all are on the same line. This is why they have to be greater than. If they're greater than, it actually kind of bows up. Those two sides, like side 2 and side 4, meet to form the triangle. But again, if the sides are less than the third side, then you'll just get this big gap here because they won't intersect. Then, if you get something equal to the third side, they'll intersect, but they'll intersect at a point that's on the line as opposed to above it or below it. That's why it has to be greater than. Any two sides have to be greater than the third side. You might say, well, 2 plus 5 is 7, and 7 is greater than 3. Yeah, but 3 plus 2 is 5, and 5 isn't greater than 5. It has to be greater than it. Therefore, the first triangle is the only real triangle in this drawing. Would the real triangle please stand up? Let's look at some examples. If I gave you, in number 1, a triangle with side length 5 and 12, what are the possible lengths for the third side? Well, we should be able to plug it into this triangle theorem and say that if we add any two together, the third side has to be greater than that. So we should be able to say that our third side, we'll call it x, should be greater than 5 plus 12. Which makes sense. We should also be able to say that whatever we add 5 to should be greater than 12. Like x plus 5 should be greater than 12. So if 12 is the longest side, whatever x is should be greater than 12. Or whatever x is plus 5 should be greater than 12. And if x is the longest side, then 5 plus 12 should be greater than that. So we can form two different inequalities based on that. We should be able to say that x plus 5 is greater than 12, or that 12 plus 5 is greater than x. And you might say, well, why don't we say x plus 12 is greater than 5? Well, because 12 is already greater than 5, and so anything you add to 12 is going to be greater than 5. You can take these three inequalities and just substitute the numbers in. We know that one side is x, we know that one side is 5, and we know one side is 12. And so you can just plug them into all three and you'll get your three inequalities. So let's go back and let's actually solve these. Well, we're going to use our algebra skills to find out what the possible lengths are. What plus 5 is greater than 12? Well, if I subtract both sides, or 5 from both sides, I get x is greater than 7. Any number greater than 7 can work for x, like 8. I also need to solve this side. 12 plus 5 is greater than x. Well, 12 plus 5 is 17, and that has to be greater than x, or x has to be less than 17. And that's really, really bad handwriting, so we're going to erase that and rewrite it. 17 is greater than x. So here we have two inequality statements. X has to be greater than 7, but less than 17. So those are our possible values. Anything greater than 7, but less than 17. And we can actually write that as one answer. X has to be less than 17, but greater than 7. We can write that all in one statement. Let's look at the second one. Number 2. If we have one side of 2 feet and one side of 4 feet, then our third side, we'll call this one y, okay, still has to fit the same criteria. If I add 2 and y, it has to be greater than 4. If I add 4 plus 2, it has to be greater than y. You might say, why don't you say y plus 4 is greater than 2? Because 4, again, 4 is already greater than 2, so anything I add to it will satisfy that inequality. So I can just erase that one, just like I did on the other side. But now I have to solve these two. If I subtract 2 from both sides, I'm going to get y is greater than 2, because 4 minus 2 is 2. Anything greater than 2 will satisfy my third length. Then we solve this side. 4 plus 2 is 6. 6 has to be greater than y. So as long as y is less than 6, but greater than 2, it will satisfy the third side. Anything in between 2 and 6, 3, 4, 5, will work there. So, I want you to do the same thing for number 3. Set up two inequalities that will help you solve for your missing side. Let's call the third side z. Okay? And so you don't have to solve them, but I do want you to set them up. What is an inequality that you could write, or two inequalities you could write, that will help you solve for z being the third side? Pause the video and take a minute and look at it. Okay, if we look at our two inequalities, we follow the same format that we did. We say z plus 25 has to be greater than 25. And we also say that 25 plus 25 has to be greater than z. Now, if I solve these two, if I subtract 25 from both sides on this side, I get z has to be greater than 25 minus 25 is 0, so z has to be greater than 0. And then on this side, if I add 25 plus 25 is 50, and that has to be greater than z. Z has to be less than 50 but greater than 0. So we can write an inequality. You learned that these in algebra were called compound inequalities, meaning there's more than one inequality statement being used at a time. And if you look at what we've done so far, we've taken the smallest number plus x, or plus our variable, our third side plus the smallest side has to be greater than the largest side. For example, we said whatever side, in number 1, whatever our third side is, x, if we add it to 5, has to be greater than 12. And again, just look at these three images, okay, these three inequalities, and label your sides. You don't have to be perfect. It's just got to be close. Let's say, for the next problem, that we've got a triangle with side 5 and side 8. Well, what if 8 is our largest side and 5 is our smallest side? Then we'd be looking for that middle one. You might say, well, what if x is the largest side? You're right. That's another possibility. Maybe this is 8 and this is x. It really doesn't matter how you put it, because these three inequalities will show us what x has to be. Well, now, let's say I'm going to solve this first one. AB plus BC has to be greater than AC. Well, if I substitute everything in, AB is 8, BC is 5, and that has to be greater than AC, which is x. There's one inequality I have to solve. Another one is this one. AC plus BC has to be greater than AB. Well, AC is x, BC is 5, and it has to be greater than AB, which is 8. There's a second one I need to solve. The third one is AB, which is 8, plus AC, which is x, has to be greater than BC, which is 5. So, what I have to do here is solve these three inequalities. Now, what I want you to do is pause the video, solve these three inequalities, and find out what statements you get. Go ahead and do that now. Now, if you stopped for a second, pause the video, and solved the three, these are what you're going to get. You're going to get x is less than 13, x is greater than 3, and x is greater than negative 3. The only problem is, when I'm building something, I can't ever use negative distances. Okay? If my boss asks me what the length of a house is, and I tell him negative 25 feet, he's going to kick me in the face. Negative 25 feet doesn't exist when you're building something. Okay? If you're measuring, or if you have quantity, a negative number can mean that you owe, but when we have a triangle here, I can see that this has a distance. Okay? That distance should be measurable. I can't measure it as negative. So I'm just going to cross that negative one out. And what I get left with is 13 is greater than x, and x is greater than 3. Well, now I'm going to use that information that 13 is greater than x and x is greater than 3 to write my inequality. And I'm done. Notice how we used the actual theorem. Okay, we just replaced what we knew. We knew that one side was 5 and one side was 8. We plugged those two sides in and said, okay, we're solving for x. And you can plug them in any order. You can make 5 the largest side, 8 the smallest side, x being the third side. And the inequalities are going to help you solve for your missing value. Now, here we know that the third side has to be greater than 3, like 4, but at less than 13, like 12. So any number in between these two could be a third side. But we used our theorem to help us set it up. Now let's look at this problem right down here. We're told to list the sides and angles in order from smallest to largest. Well, that's just fine and dandy, except that I need to know what all the angles are and what all the sides are first. Okay? Let's look at angles first. This angle is 33 degrees. What's this angle? I hope you're saying out loud that it's 90 degrees, because you're right. This little perpendicular box down here means that that's a 90-degree angle. Well, if that's 90 and that's 33, how much is that angle? To solve this, you have to know that the inside of an angle or a triangle adds up to how much. You might be saying to yourself 180, and you're correct. Well, we can use subtraction and say 180 minus 90, which is 90, minus 33 gives me 57. That is my third side. If I just take 180 and subtract both of the two angles that I already know, that will give me my third side, or my third angle, excuse me. So now that I know all three angles, I'm going to list them from smallest to largest, just like it tells me. The smallest angle is which one? Okay, I hope you were saying angle G. What's the second smallest angle? It's angle H with 57 degrees. Then the largest angle is which one? Angle F. Good job. We got angle G was 33 degrees, and that's the smallest. Angle H is 57 degrees. That's the second smallest, so we put it in the middle. And angle F is the largest, as 90 degrees. Now, let's kind of review one interesting fact. We don't know any of the sides. Not one of them. They don't give us any lengths. So when they tell us to list them in order from smallest to largest, what information can I use to list my sides from smallest to largest? And I hope you remember that we can use the angle measures to identify the sides. What we talked about at the very, very beginning was that the largest angle represents the longest side. The smaller angle represents the shortest side. So we can use that information alone to say the largest angle, or excuse me, the largest side should be across from the largest angle. The smallest side should be across from the smallest angle. Now they want us to go smallest to largest, so we'll just do it backwards. What's the smallest angle? It's 33 degrees. We already figured that out. Well, what's the side opposite angle 33? It's FH. Based on what I know, the side across from the shortest angle, or the smallest angle, should be the shortest side. So FH should be the shortest side. Again, it's across from the smallest angle, so it should be the smallest side. Well, what's the largest angle? 90. We already figured that out. Well, let's look at the side across from the largest angle. It's GH. That tells me that GH is the longest side. It's the longest side because it's across from the largest angle. I got my smallest angle across from the smallest side, my largest angle across from my largest side, and now I can just say that my middle one, or the third one, is across from the middle side, which is just FG. I just listed the sides from smallest to largest, and I didn't know anything about the sides, but I did know the angles. I should have been able to do that all day long. Or I should be able to say FH is the smallest side, GH is the largest side. Knowing that information, I should have been able to list the angles also. Be able to go from sides to angles and from angles to sides. You know that the longest side is going to be across from the largest angle. The smallest side is going to be across from the smallest angle. So you should be able to say, knowing the sides, I should be able to get the angles and list them from smallest to largest. The complete opposite. If I give you all the angles in a triangle, you should be able to say, oh, this is the largest angle. Meaning the side opposite is going to be the largest. Here's the second largest, meaning the side opposite is going to be second largest. Here's the smallest, so the side opposite is going to be smallest. And if you're given the angles of a triangle, you should be able to list the sides without even knowing anything about the sides, which is exactly what we just did. You were given two angles, you found the third angle, and then you listed the angles from smallest to largest. Then we took what we knew about the sides and the angles being, correlating, meaning small, small, large, large. The smallest side across from the smallest angle, largest side across from the largest angle. And we took that information and we built a list of sides based on their angle measures. That's totally fair. Your turn. You're going to take what you know about triangle inequalities you're going to take what you know about the third side and how you can write the 3 inequality statements, and you're going to apply those 2 concepts to your homework tonight. So let's stop and take a look at it.